Hello and welcome to another video. This one we're going to be covering the match statement in Python, which is brand new at the time of recording this video. It hasn't even actually landed in any releases of Python, so I figured I'd give you a sneak peek and explain all of the ins and outs of it, and kind of get you up to speed on it. But anyway, let's jump into it. Okay, so to frame this discussion, before we even get started talking about match, I wanted to talk about switch statements in other programming languages. I'm going to give you an example if you haven't seen one before. Let's see, I'm sure I have some. Let's see, do I have a switch in some C code? That's probably going to be the easiest to start explaining from. I do, perfect. Let's see, output, output paths. If we copy this, okay, cool. So if we look for a switch statement here, this is some C code from libsass Python, which is Python bindings for the libsass SCSS compiler. But what a switch statement is in other languages is a statement which takes a particular value and then matches it against exact equality with a bunch of different possible choices. So in this case, what's happening is we're getting a tag from a Sass value, and then we're checking what type it is based on some enumeration constants here. And inside each case block, there's some code. Depending on the language, there's either implicit or explicit continuation. In C, there's implicit continuation, so if I didn't have these breaks here, it would just run all this code. And so generally, the best practice in C is to have, case something, code, and then break. And so you can see there's a whole bunch of cases here. I don't have one here, I think, but there's also a default situation. If it were to, if it were to pass through all of those other cases, you can say default, and this is kind of like an else block in an if statement. But why am I telling you all this? Who cares about switch? The reason that I bring this up is Python for the longest time has not had anything close to switch, and so you essentially had to write a bunch of if statements that looked like a switch statement. And this was one of the many criticisms of Python. It didn't have switch. What are all these ugly if statements? What's going on there? And in a lot of ways, match is seems to be an attempt to solve this switch problem. However, match is very much not a switch statement, and I will show you some of the differences there. Mostly match is a lot more powerful than switch, and at the same time also doesn't have some of the same syntax guarantees as switch does. But anyway, I wanted to kind of frame this as like, switch is a thing in other languages, but it hasn't been a thing in Python, and has often been something that's kind of problematic there. All right, but let's talk about match. So in talking about match, I want to first tell you how you can get a version of Python that has match. Note at the current time, there are no releases of Python that contain match. However, presumably you're watching this at some point in the future, and you'll be able to get this in the final release of Python 3.10, assuming that it doesn't get booted by the time 3.10 is released. We'll see, because it's very controversial. I won't really go over my opinions on it in this video, other than I don't think it's actually all that useful in Python, or I don't think it's a good addition to Python given the complexity. But if you want me to rant about that, join my stream, and I'll ramble on about that forever. But assuming that it actually lands in Python 3.10, the final release of Python 3.10 will contain the match statement. Or if you are up to date on alphas, 3.10 alpha 6 should be the first release that contains the match statement. You also have a couple other ways to get the match statement if you're up to it. The one that I'm going to be using today is building Python from source. I have already built it from source. So you can see if I run /python here, I'm running 3.10 alpha 5 plus at this particular revision, which is just after the match statement has been merged into CPython. Another option that you can do is you can add the nightly PPA of dead snakes. So if you do, you'll probably do Pseudo if you're running it outside of a Docker image, but I'm in Docker because I don't really want to do it to my host machine. But you'll do add repository PPA : oh, that's gonna be off screen. Add repository PPA dead snakes /nightly. And these are a set of builds that I do once a day that contain a very recent version of Python. You can see some blobs here. Available packages 3.10. You'll say enter to accept it, and then you'll do apt-get install Python 3.10, and then you'll have a functional version of let's see, apt or apt install, and you might need sudo as well. Python 3.10. I don't because I'm in Docker. And this will install a set of packages. And we should see from this that we have a version of Python 3.10 that has the match statement. So if we do Python 3.10, match one, case one. This is kind of the most trivial match statement. But anyway, that's 2 ways that you can get access to this. But presumably you're watching this in the future, and so that's not super relevant. But anyway, let's talk about the match statement and kind of the various types of syntax that it can have. It looks a lot like a switch, so you can see kind of the syntax that I started writing here. You have match, then you have some expression. This is kind of like the thing that you would switch on. And then you have a series of case statements which attempt to match the thing that you're switching on. Or matching on. Oh, that's gonna be real confusing. But I'm gonna just show you some basic examples and jump into that. Okay, so let's do a very silly, simple program. This program is going to have a variable that is sim status code, and we are going to do a, let's call it status code. We're going to do a match on status code. Note that my text editor doesn't have proper highlighting yet because the syntax is brand new, hot off the press, but presumably in the future it will. And we're going to do a match on status code, which means we're going to try and check a bunch of different values here, and we're going to augment this program as we go along. Kind of the most basic thing that you can do in a match statement is match it against a bunch of constants. So let's say, case 200, print status, okay. Case 400, what is that? Bad request. I don't really remember exactly. Case 404 is, not found. Case 418? 418? That one's is that I'm a T-bot? And I am a T-bot. And yeah, so we'll just start with that. So this, to me, looks a lot like a switch statement, and it actually executes very much like a switch statement. So if we run this, python t.py, you'll see that the 404 tried this case. It didn't, 404 doesn't match 200, so went to the next one. 400 doesn't match 404, so went to the next one. 404 matches 404, so this bit of code here, and it exits the switch here. Now note a couple things. I talked about implicit fall through. There's no implicit fall through in Python. In fact, there's no continuation in Python, so you can only run disparate code here. So if you wanted to also do some side effects of 418, you wouldn't be able to do that after this. As soon as one case is matched, it runs that code and then the block is exited. But this is the most basic form of match, so just matching a bunch against literal constants. And these constants can be any sort of literal value that you would have, except for ellipsis, which I find a little bit strange. But so if you had, foo as a string here, print match bar case foo print matched foo. So you'll note here that you can match, strings, you can match numbers, you can match booleans, you can match null or none. What else? Is that it? Strings, numbers, floats. We'll actually get to some structured type matching later. So there's tuples and lists and dictionaries, but we'll get to that in a bit. But one thing that I find is a little bit annoying about match, and we'll get to this right now, why not? You might think, okay, I can take these particular expressions here. It's usually a bad practice in programming to have magical numbers, and so you might say, oh, I want to, abstract these out into constants, and so you might say, HP okay equals 200, and actually let's just do one of them so that it looks a little bit funny first. Let's just do HTTP not found equals 404, and we're gonna change this to HTTP. Actually, we'll do HTTP okay. And we'll show a syntax error that's actually pretty useful here. So you might think, oh yeah, I can just make this a constant and then match that as part of a case statement, but you would unfortunately be wrong. And if we run this, you'll see that we get a syntax error. And this brings us to our next topic, which is wildcards. If you have a name in a case statement, this doesn't do name lookup. What this instead does is it's a named capture. And if you have just a name on its own, it's a wildcard. So this case statement here matches any value and assigns the value into the HTTP OK variable. So if we were to, comment this code out here, comment, and our value that's going through here is 404. It doesn't match 200, but you'll see if we run this code here, it's always going to go into this status OK block, and it's actually going to assign this variable HTTP OK. And this is a wildcard. So you can see that it assigned 404 to HTTP OK, which actually clobbers this variable up here, which is kind of funny. But yeah, that's kind of our first kind of gotcha with the match statement, is that names on their own are wildcards. There's also a special syntactical wildcard, which is the underscore. And this underscore actually doesn't assign a variable. It is kind of a special case here, which I find a little bit weird. But yeah, underscore matches anything but doesn't cause any assignments to happen. So you can see here that underscore is not defined, although it did try and run that because the underscore matches it. And that's what wildcards are. Now you might ask yourself, hey, that's kind of unfortunate. How do we get around this? How do we still match HTTP OK or print OK? How do we still match stuff as named constants, but make it compatible with the match statement? And the way you can do that is by nesting things inside of a namespace. So if it's a dotted name, it will still do a lookup, which again, kind of a weird rule, but let's see, status codes. And so if you did status codes HTTP bad request equals 400, HTTP not found equals 404. We did status codes here and status codes here and status codes there. So now this is a valid match expression, and you'll notice that this is actually going to match these exactly. So if we run this now, we again get our not found example here. And this is because dotted names are treated specially, presumably so you can use enumerations or imported modules that have constants in them. But names are wildcards, dotted names are not wildcards. The next thing that I wanted to talk about is the pipe character, which allows you to combine multiple different match expressions in a single case statement. So maybe we wanted to, match both bad request and not found in the same case statement. And so what we can do with that is put a pipe here. And I don't know why binary OR instead of literal OR was chosen here. Or logical OR. I would have probably, if I were designing this, I would have designed this as, logical OR. But nope, it's the pipe character. Perhaps this is taken from other languages, so other languages probably use the pipe character, and that's probably why it was done that way. But now you'll see, God for X error. And you'll see if we run this now, you'll see that we went into this got 404x error. And again, even though this case statement would have been matched by the 404, because it was matched by this one, it doesn't continue execution there. So you can use a pipe to combine as many cases as you want. And that brings us to kind of our next bit of code here, which is the actual structured part of structural pattern matching. And again, a lot of this information comes from the PEP, so if you want to read it, it's PEP 634. So this is where the match statement really differs a lot from a traditional switch statement, which is the actual pattern matching part of it. We're kind of going to throw away our status code example and move on to a completely different example. So let's just get rid of our code here. And this is kind of where it differentiates itself a lot from where you would see normal Python. And so what we're going to do now is we're going to have an X value here, and I'm just going to assign it a list that's foo baz for whatever reason. And we are going to do a match statement on this. And we're going to try and match this X here based on just its first member of this list here. And the way we can do that is by using case statements that structurally match that. And we also want to, let's say, assign this to some other value. So again, here we're using a name capture to grab this value here, and we're trying to match here. Let's actually put something else first as well. Print got Baz and y equals, and let's see, print got foo and y equals. So what's happening here is this case expression, it looks like a list, but what it actually means is this is a sequence that has two elements in it, and the first element is Baz, and the second element will be captured as y. And again, I mean, this is similar to that, except instead the first element must be foo. And so it is a structural matching of this particular object here. And you'll see if we run that. It tried this statement, Baz didn't match foo, so it skipped this. And then it went to the second case, foo did match foo, so it assigned Baz to y, and that's why we get y equals Baz at the end. And actually, these cases here, the types don't really matter. If you're interchanging between lists and tuples, both lists and tuples here just say, you know, it's a sequence of length, whatever. So you can see that even though this is a tuple and this is a list, these will still match here. If we were to add another thing here, and again, let's add a base case down here, print nothing matched. Again, I'm using a wildcard here, the special underscore wildcard. You'll see that nothing matches if the lengths are different. You can, however, use a star expansion on these, and this is very similar to the unpacking and packing assignments that you might see in Python. If I did star y on these, what's going to happen is this is going to capture every other value in this sequence. So this would allow you to match, you know, a prefix of a sequence here. So you can see here that it assigned Baz foo into y when it matched here. And so you can kind of use star expressions there to match different things like that. So I talked about matching lists and tuples, basically sequences. You can also do matching with dictionaries, which means that we finally get a dictionary unpacking syntax in Python. It's not a very good one, but we do get one. Let's do foo bar baz womp. I'll just show you a quick example of this. You can make a case statement that has a dictionary literal in it. I mean, it's not actually a dictionary literal, it's a dictionary match literal, so it's a little bit different. And so you can unpack particular values from this. Print the dictionary had a key foo with value foo, and let's actually just put bar in here. Oh, actually, we don't have a key bar. Okay, cool. Bar. And again, these will be run in order, so that only the first one that matches is going to be hit. Nothing matched. And so if we run this, you'll see that we matched this here, and it assigned the value of the foo key. So we got bar out from this string here, and that is because the structure of this mapping type matched here. That covers most of the structural parts of structural pattern matching. The last thing to talk about is type matching. And the way to do type matching in this is actually kind of interesting. And again, this is something that surprised me when I did this as well. Let's see, matched an int. The way you do it is you use a type name. This can be either a name or a dotted name, and then you use parentheses after it. We'll actually talk about what goes inside these parentheses in a bit, and we'll make a class up here as well. Let's see, print matched a float, and then case C, print matched a C. Case underscore print matched nothing. Okay, so if we take this case here, you'll see that I didn't actually assign x. Let's assign x to a C value here. So what's going to happen here is this essentially evaluates as an if statement that says the value x is an instance of int. And we'll talk about the arguments in a second. The arguments have some additional behavior here. But you'll see here that, it wasn't an int, it wasn't a float, but it was a C, so it did match here. Now note that this looks like a call to C, but it actually doesn't invoke C at all. We can actually show that by, giving our C class constructor here and giving it a value here. This would be an error if we just called C on its own. So you can see if we did y equals C, you'll see that we get a type error because it's missing a positional argument. However, the expressions inside of cases of match statements are kind of bogus. They don't really mean, what they don't mean what they say. And so if we run this, you'll see that it still matches this, even though, this doesn't match here. Now you can customize the matching of these classes based on either positional or keyword arguments. I'll go over keyword arguments first, since I think they're a lot easier to explain. Here I'm saying with C having x equals 1, this will look up the x attribute on the instance of x here and check the value against 1. So you can see if we did x equals 2 and x equals 1 here. In our case, our C object has self.x equal to 1, and so it should match this one here. And you'll see if we run this, it does match this. So any named arguments inside the parentheses here will be looked up as attributes. The other thing that we have here is positional arguments. So let's actually do another case above this. Case C1. And if I run this right now, it should actually error. Yeah, so you can see here, we got this kind of confusing type error here that says C accepts 0 positional subpatterns when given. And so what's actually happening here is positional arguments are looked up against a match args sequence inside the class. So if we, and this is another new magic method added to classes in Python, specifically for the match statement. And the way it works is if you do match underscore args double underscore and assign this to some sequence of strings, it will look up those particular string names as attributes on self. So by setting match args equals x here, what C1 will do is it will compare 1 against getter x, and in this case, 1 will match the 1 up here. A lot of the built-in types in Python have added match args such that you can use them in the match case statement. So things like name doubles and such will have things like this. But you can see now that it is matching C1 because I have done this here. Note that we can also, it's a little bit silly to repeat the value here, but we only have one attribute here. So if we did, C1, comma 1, you'll see got multiple. Oh, I guess you can't duplicate them. Whoops. Let's do x and y. X and y, self.y equals 2. And so if we did 1, comma 1, and we did 1, comma 2, you can do that as well. So you can see that these two attributes here matched the x and y from this. And again, this is another kind of magic method that you need to remember if you're going to write classes that are used inside matching. Though I would recommend not using match args. I find that the named version of it makes a lot more sense to me and is a lot more readable. There's one other thing that I want to talk about. You can bind names inside, or you can bind matched expressions in here using the as keyword. So let's say we just go back to having this as, an integer. You can use the as expression to do an assignment of this value here, like whatever was matched here, matched val, and use that as statement to matched val to assign stuff here. So you can see that if we run this now, you'll see that it reassigned x as 15. Now this is a bit of a silly example because you could just reuse the original expression up here, but say that you had x raised to the 3 or something like that. So maybe you don't actually have direct access to the name here, and so you want to reassign it to some other value as a side effect of matching here. So you can do that with the as statement. The last thing is a little bit of like a shortcut slash workaround here. All of the case statements allow for an optional if condition on the end of them, which must be true in order for that expression to happen. So if we say, if, x greater than 10, for instance, you could force this to only happen if x is greater than 10. Now note a little bit of a weird thing. This is actually, I think, the first bit of Python that has explicitly undefined behavior. If the if expression is, false, all of the side effects of the case matching always happen. Will already happen. So if int did match, it will assign matched val even if this isn't run here. So you can see down here, if I print, after matched val equals, you'll see that even though that it matched nothing, it still had a side effect of reassigning this variable, which to me is a little bit weird. I feel like this is, I'm not comfortable with this. We'll put it that way. But that's kind of the last little bit of a match. A few common questions that people have asked me so far are, well, the first and the most important one is match faster than if statements? And the sad answer is that match is ever so slightly faster than if statements, but not really. The reason that it's not really faster is each case statement must be evaluated in order. So, if this was the one that was matching, it still has to check if it's an instance of int, instance of float, looks like a C that has these two values, looks like a C that has these two values, looks like a C that has x equals 2, and then it would finally match C. So it's still going to execute as if it's kind of a linear if stack here. So you're not actually gaining any performance here. Now note I said it's slightly faster than an if statement, and this is because match has very, very specialized bytecode that executes mostly inside of the interpreter instead of rereading all those values over and over. So like for instance, it only computes or reads the match expression once and then does all of its comparisons against that, instead of, in an if statement, you would load a local variable over and over. But the difference between that execution is going to be almost 0. One thing that's a little bit disappointing about this is because match is so complicated, it's not possible to, it's not possible in most cases to optimize a match statement into a direct jump, which is common in a lot of languages that have switch. For instance, in C, you can essentially make what are called computed go-tos, and this is actually how the virtual machine of CPython works. It detects particular bytecodes and jumps to particular code offsets and makes those work directly. But we can't really do that with the match statement because of all of the power that the individual case statements have and the complexity of each of them. One other thing that I meant to cover, but forgot to, so this is another recording, is that the match statement also introduces another concept into the language, which is the idea of pseudo keywords. And the reason for this is the match statement introduces essentially 3 new keywords, but a lot of these are common variable names that already exist, and those are match, case, and technically the underscore is also introduced as a pseudo keyword. And what this means is that Python will, based on the syntax position in the file, decide whether something is a keyword or not. This allows it to be, backwards compatible with using variable names such as match, case, and underscore. So I want to show just one quick example of that to reassure you that you can keep things still named the same as before, even though the the thing is called match now. And a very, very common variable name for matching was, when dealing with regular expressions, re.match, regular expression first, object second. And so you could imagine a match statement that looks like match match, which again looks a little bit silly. Case none, print it did not match. Case, you can even do case case. This would be a name capture that assigns the variable case. It matched case, and you could imagine the same as with having a variable that's an underscore as well. Like you could do match underscore if you really wanted to. But if we run this, you'll see that we get it matched, and if we break the regular expression so that it doesn't match, you'll see that it did not match. And so this is kind of a new concept, which is going to be tricky for syntax highlighters and other stuff. I'm not really sure how they're going to handle it without having to do a full grammar parse, but yeah, the case and match and underscore pseudo keywords are kind of a new concept in Python. But anyway, hopefully this was helpful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.